Hello, 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 everybody. We're going to get into question number 4 on the 2016 midterm, but before I do, a quick correction. I was just reviewing my work just to make sure I had it all nice and neat and clean, and I actually realized I goofed on some minus signs for question number 3. I was a little too hasty at the end trying to finish off. I'll be honest, I was panicked because I was onto another piece of paper. And profs try and make things look nice and neat, but this minus and this minus should have turned into a plus. So it should be +2, not -2, and that fixes things up. Okay? So there we go, my mistake. I caught it like 2 seconds after I finished off the recording as I was just double checking my arithmetic, but I probably should have made a point of checking my arithmetic on the video because that's something you guys should be doing as well so you don't make goofs like that. Alright, but we're on to question number 4 here. Question 4, 9 marks. Write out the form of the partial fractions decomposition of this scary, scary looking thing. Do not determine the coefficients. Okay? Now, it looks terrifying. It's 9 marks, so you might be really scared that there's a lot to do, but there really isn't. Okay? What we've got to do here is say, okay, it's not about whatever's on top. We don't care what's on top, as long as its degree is less than what's on the bottom, and it certainly is. The degree of the top is 2, where the degree of the bottom is 4, plus 3 is 7, plus 2 2's is 11. Okay? Don't have to worry about breaking anything like that up. Okay? Instead, we have to factor the denominator into irreducible linear terms and irreducible quadratics. Well, all linear terms are irreducible. So it's just a question of, okay, this x squared plus 5, that's a quadratic. It's an irreducible quadratic, but you might want to double check that. More importantly, this x to the 4 plus x. If the degree is more than 2, you can guaranteed to split it up and get another factor out. And so I can see that an x will come out of here. So we'll get x cubed plus 1. Okay, now we might have a little bit of difficulty with this one, but if you're stuck, try plugging in some numbers. What cubed plus 1 would be equal to 0? So what could be a root here? Well, something plus 1 being equal to 0, that something's going to have to be -1. What's the cube root of -1? -1. So I can see -1 is going to be a factor here as well. Okay? And now I could either, factor this in my head, or if I got stuck, if I said, gee, I just don't know what other factor I'm going to get, I can always fall back on polynomial division. Okay, that's one of the great uses of polynomial division. And so we'll get, x squared here, x cubed plus x squared, minus x squared, bring down the 0x, so this will be minus x squared minus x. You'll get x plus 1, and it'll be clean. There will be no remainder. And you can always take that and plug it back in. Okay, that's a nice, neat little use. And now if we thought, hey, this looks reducible, try guessing some values. But, if you try it for a while, you're going to find that, no, you can't actually reduce this. And if we just double check, a negative b squared minus 4ac is less than 0. B squared here is -1, so -1 squared is 1 minus 4ac. And that's going to be -3, and that is indeed less than 0, so this is irreducible. Good, useful to know. All right, we've got a bit more space here. What about our other one? X cubed minus 3x squared minus 10x. Also, you should double check, just because we gave you a quadratic doesn't mean it's irreducible. Here the b squared is 0, because there is no factor of x, or no term with an x here. Minus 4ac is -20, so this one here is also irreducible. And you should probably mark that somewhere on the page to get full marks. Alright, so x cubed minus 3x squared minus 10x. Again, they're really being nice and giving me something that has, I'll just double check that I got the numbers right. Yep. They're being nice, something with x here pulls out, and then we get x squared minus 3x minus 10. Now we could play around with this. We could try and factor it. Or if worst comes to worst, we can always use the quadratic formula. Okay. However you can do it, you go ahead. But you can get more linear factors here. So, just to recap, my denominator is, I've got 2x squareds. Sorry, not 2x squareds. I've got 2x's making x squared. 2. I've got 1x plus 1. Got 1x plus 2. I've got a single x minus 5. I tried and grouped my linear terms together. And then I've got a couple irreducible quadratics, one of which is squared. Alright, so they're really testing us with everything here. And so the partial fractions setup is, okay, each linear term you get a constant, and you just keep going up until you've exhausted the powers there. And I keep a little check underneath sometimes. 1 constant for the x plus 1, 1 for the x plus 2, 1 for the x plus 5, or x minus 5. They're not asking us to double check these. Now for the quadratics, we have to remember that we get a generic linear term on top, not a generic constant term. And now for this irreducible quadratic that is squared, we're going to get 2 terms. Just like we got 2 terms for the x squared, the linear term squared, well, you also get 2 terms for quadratic terms that are squared. And we still put generic linear terms on top. And there we go. That's our answer. So what did I have to do for this question? It was all about the factoring, just because they only wanted the setup. If it were a different question, we'd actually have to go through, solve for the coefficients, and plug things in. But if that's the case, the factors here, there won't be so many, and they'll be a lot nicer. For example, if we were going to integrate this last one here would use one of those really big blocks that we talked about in class with like a really long reduction formula. You don't need to know something like that. No one but a crazy sadist would actually ask you for that, and that's not me, and that's not Professor Pinsino, so you're going to be fine. Okay? But, maybe expect a linear term, or maybe something like an x squared plus 1 that turns into an arctan. Those are fair game if we're asking you to actually calculate. But they weren't in this question. They just wanted the partial fractions form. Okay? So that does it for question number 4. Up next, question number 5.